Hi everyone, this is Matthews112358. In this lesson we will talk about limits. The basic notation for limits is written like this. It's a limit as x approaches any integer value a, or not even an integer, any value of a function which equals a limit. So suppose we have the equation y equals x. So let's draw the graph. Here, once you draw it, so if you want to find the limit at x equals 2, let me write a limit as x equals 2 of the function x equals what? So what it's asking is at x equals 2, what is this value? What's the y value? So in this case, all you would do is just plug it in to find out. So plug it in and you just get 2. But it's not always that simple, where you can't always just plug in a value to get the answer. If you have the equation limit as x approaches 2 of x minus 2 over x squared minus 4. If you want to find the limit as x approaches 2, in this case you can't just plug it in, because if you do, you would get 2 minus 2 over 2 squared minus 4. And once you do the math, equals 0 over 0, which doesn't exist. So in this case, you would have to do something else. So you would have to, let me just write the question again. Limit as x approaches 2, x minus 2 over x squared minus 4. In this case, you would have to factor it. So it would be x minus 2 over x plus 2 times x minus 2. So then you could just cross cancel, and that would leave 1 over x plus 2. And once you plug in 2 into that, it would just be 1 over 2 plus 2, which equals 1 over 4. So sometimes in limits, there's also something called right-hand limits and left-hand limits. So in a right-hand limit, it's written like this. So limit as x approaches 5 from the negative side, or from the positive side if you're doing from the right-hand limit. And if you're doing a left-hand limit, it would be written as limit as x approaches 5 from the negative side. So what this means is that sometimes, like, suppose we have the equation y equals x plus 2. Then in this equation, if you draw the equation, at x equals 5, I drew the graph too small, but this would be, suppose this is 7. Suppose it was right here. That would be 7. So this is the point. Well, in this case, let's make it a little smaller. If this was 5 and that was 7, a right-hand limit asks for when it's coming from that direction. So suppose it was coming from the right side. So let me make the graph a little better. So this would be 5, and this would be 7. So the right-hand limit would be coming from the right-hand side. So a right-hand limit comes from this side, so the points keep getting smaller and smaller, while a left-hand limit would be points approaching this side. So if you took a random point 1, I suppose. So if you plug in the limit equation is limit as x approaches 5 from the left-hand side of x plus 2. If you plugged in 1 to that, it would be 3. So then if it would be 1 comma 3. If you plugged in 2, it would be 4. If you plugged in 3, it would be 5. And we already know that at 5 it's 7. So we already know the limit to this is 7. So as we go to 4, it becomes 6. As we go to 4.5, it becomes 6.5. So the closer and closer we get to that value from the left-hand side, that's the limit from the left-hand side. And the same for the right. So in this equation, this would be a piecewise function, where the equation went like this. From here, it jumped to here. So in this equation, the equation would be written like this. So it would be y equals -2 for when x is less than 2. And it would be 2 for when x was greater than or equal to 2. So in this, to find the limit, we can't find the limit because another theorem states that the limit from the left-hand side of a function has to be equal to the limit of the right-hand side of the same function. So if they aren't equal, then the limit does not exist. So here. So let's take the limit of the bottom one first. So the limit as x approaches 2, because this is point 2, in the graph -2, in the equation -2. So no matter what point you plug in, the answer is always going to be -2. So it keeps getting closer and closer. It's always -2, but it keeps getting closer and closer to this point. But at this point, it doesn't exist. So the left-hand limit does not exist. So the left-hand limit, because it's approaching -2, it's -2. But now if you want to do it from the other side, that was from the minus side. Now if you want to do x approaches 2 from the positive side of 2, no matter what point you choose, it's going to keep approaching 2. So this would be 2. As you can see here, -2 and 2 aren't the same number, so they don't exist. So the limit does not exist, because -2 does not equal 2. In a function where it's y equals x squared, if you wanted to find the value at 2, suppose this was 4, then if you chose the values from the left-hand side, you could see that they were getting closer and closer to 2. Because at 0, it's 0. At 1, it would be 1. But at 1.5, it would be 1.25. Or it would be 2.25. So no, as it keeps getting closer and closer. And once you actually hit 2, though, it's 4. If you go from the other direction, at 5, it would be 25. At 4, it would be 16. So as you got closer and closer, so at 3, at 3.5, it would be 12.25. So in this case, at 2, 4 would equal 4, so the limit exists. Sometimes when limits go to infinity, we have to find out different ways to do it. In the graph 1 over x squared, as x approaches infinity, what's the limit? So in this case, let's draw the graph. In this case, it's an asymptote. So the more values you choose, it keeps getting closer and closer to 0. So as it approaches infinity, it's going to keep getting closer and closer. Because if we choose 10, it would be 0.01. If we chose 1, it would just be 1. So as the number gets bigger, it's getting smaller. So in this case, what you would have to do is look at the equation, look at the graph carefully. As it's getting closer and closer, the numbers keep approaching 1. The numbers keep approaching 1, or 0. So it goes from 0.1 to 0.01 to 0.001 to 0.00001. Or if you want to choose a really big number, it would become really big. So if you keep looking at the pattern, you can see that it just went to 0. So the limit, as x approaches infinity, of 1 over x squared is equal to 0. Sometimes, however, it might be a little hard, so there's this one trick. So if the limit, as x approaches infinity, is of a polynomial. Suppose x cubed plus 3 over 2x squared plus 5. You look at the number on the top, which number has the biggest power. In this case, it would be x to the third, and on the bottom, it would be 2x squared. So, since the number on the top has the bigger power, the limit would just go to infinity, which means it does not exist. This time, however, if we change the equation a little bit, so that this number was 4, then it would be, the biggest number on top would be x cubed, and the biggest number on the bottom would be 2x to the 4th. Once you looked at it, you could tell that the bottom number was bigger, so in this case, the limit would just go to 0, which means it exists. If you looked at the same equation again, but with the same power, in this case, the biggest power on the top is x cubed, and the biggest power on the bottom is 2x cubed. So when it goes to infinity, what you do is you take the coefficients of the top and bottom and just put them over each other, and that's the answer. So this limit would go to 1/2. If we were to do another example of the limit as x approaches infinity of x to the 126th plus x to the 16th plus 90x to the 5th over, let's make it 9x to the 126th plus 8x to the 16th, then the highest power on the top is 1x to the 126th, and the highest power on the bottom is 9x to the 126th. So what you would do, you would get rid of the, not look at the x's, since they both have the same power, and just look at the coefficients. So the coefficients is 1/9, so that's what the limit goes to. The limit goes to 1/9. So this is your basic introduction to limits. Please watch more of my videos, and please subscribe. Thank you.